Hello, this is Mark Summers from Summers Technical Services. We're going to get started on our DIN rail model. We're going to break this up into 3 sections. First section will be creating the basic model. We'll do right now. After that, we'll turn it from a good model to a great model by adding global variables and applying those global variables to the model features and sketches so that we can get parametric updating model. And then step 3, we'll do a finite element analysis to do some deflection and stress analysis on our finished part model. So let's go take a look at a finished model to make sure our orientation is like we want. So I'm going to do a space bar and get my standard ISO view. This is the standard ISO view that I want to see on your finished model. And so in order to do that, if we look at the front view, we can see our shape of our DIN rail. We want to sketch on the front plane to get started. We want the top plane to be represented by the bottom of the part. And we want the right plane to be representative of the mid plane of the part because it's symmetric about that axis. And so if we do that, then we'll get our model oriented, make it easier to put in our assembly model when we start doing assembly models. So let's start a new part model, File New. We'll use our part template that I've given you. And we're going to make sure that I've got millimeter gram second down here in the units, which I do. I'm going to go grab my front plane, go to Sketch tab, and then sketch on the front plane to start my part model. So I'm going to go to Line Command and just do my sharp corner lines. And I will start over here, draw my horizontal line here, and I'm going to try to get the size approximately correct. And so the shape approximately correct. And so that's 60 millimeters right there. So I want to click there, right click select. I really want that length to be about half of that. So I want to drag this in, just make my constraints a little bit easier to do later. So that's a little bit closer to the final shape. And so now we'll keep drawing our line. And I want to watch the constraints to make sure that I get my vertical and horizontal constraints as I go. I see those yellow indicators, and when I click when those yellow indicators are on the screen, I'll know I'll get those constraints for free. And if I happen to miss one, it's not the end of the world. I can go back and add it later, but it'll make it a little bit easier for me if I pay close attention. Click the last node to make a closed loop, right click select. And obviously I missed this one here, getting a vertical line, so I can go back and select it and look at the relationships over here, and I can make that line vertical. And so now I've got my closed loop. If I drag this back over here. So my shape looks kind of odd, but it's geometrically the shape I want. So now I'm going to start doing geometric constraints to start constraining the sketch to a final fully constrained sketch. So what I do is I select these corners, I click and hold, and I drag it around to find out what I need to do as far as geometric constraints. I can see that I need this line. I want to select it, hold down the control button and select this line and make those collinear. Say OK. Now these lines are collinear. So that's one step closer to having a fully defined sketch. If I drag this other blue corner down, I've got the same problem on these bottom 2 lines. So I can make these 2 collinear, or equivalently, I could grab that line and control click this line and make them equal. It does the same kind of thing. And so there's more than one way to constrain these sketches. What else do I need to do? Well, this bottom line here is not symmetric about the right plane like I want. And so what I want to do is I want to put a midpoint on this bottom line and then make that midpoint coincident with the origin. So I'm going to go to my point command. I'm going to hover over the line without clicking. That constraint there would give me an automatic coincident constraint, but I want a midpoint. So if I move over here toward the middle, I see that indicator change to a midpoint. If I click right there, right click select, now I have a midpoint constraint for that point. And now if I select that point I just created, control click the origin, and I want to make those coincident to one another. And now that bottom line, that midpoint is going to force that thing to be symmetric. I can do the same thing with this line here. Put another midpoint on here. Go to my point command. Hover over the line. Move over. Don't click. Move over until I get the midpoint constraint. Click right there. Right-click select to get out of the command. And now I do a similar trick. I'll grab that point that's the midpoint. I'll control-click the origin. And I will make those line up vertically to one another. And say OK. Now I want to continue finding geometric constraints. I'd like to have this line here. Control-click this line. Make those equal. And now I'm going to do a similar thing over here. This is symmetric here, and so I want this line. Control-click this line. Make these equal. I could do some combinations of symmetry constraints, but like I said before, there's more than one way to tie this down. Now this thing is looking like it's geometrically constrained, and so now I'm ready for some dimensions. So I'll go to Smart Dimensions and just let SolidWorks figure out if I need horizontal or vertical dimensions. So I'll go to Smart Dimension. I don't like to dimension to corners. I like to dimension to edges. So I want to grab that line and this line, place that dimension, and based on the data sheet you pulled off of the Phoenix Contact website, you'll be able to type these numbers in. So I'm going to go through and quickly add these. Click to place and then click to change the number. And now I need some 1 millimeter dimensions for the thickness. I'll put one there. And I need another one here. And I keep adding these dimensions until, whoops, one too many ones, until everything turns black. And so right now I've got a lot of black on here, but I still got this blue line. I'm still underdefined. And so now I see I still need another 1 millimeter dimension. So I'll dimension from here to here. Make that 1 millimeter. And now when I get out of my command, I can see now everything turned black, and down here at the bottom it says fully defined, so I'm ready to get out of the sketch. Once I'm out of the sketch, I'm going to do a space bar and get my ISO view. I'm going to select the sketch. And you can see in the tree down here there's no more minus sign in front of the sketch. That means it's fully constrained, which is what we want. So I'm going to pre-select the sketch, go to the Feature tab, and hit Extrude Boss Base. And I want to type in my extrusion depth, which in my case is 2,000 millimeters, and say OK. So now I've got my DIN rail in the correct orientation, and now I'm going to add my corner fillets. I didn't want to add those fillets in the sketch because it makes the sketch too complicated. So I'm on my Feature tab. I'm going to come over and find Fillet, and I'm going to grab the inside fillets first, these inside edges. There's one. I can spin it around here, and there's another one. And then I can spin it around here. And you can see as I add them to the blue box over here. And so here's another inside bin. I can spin this thing around, but I can actually look through the part. So I can grab it that way, and I can zoom in here and grab it this way. And that fillet was, I believe it was 1 millimeter. Say OK. So now I can look at the front view and see that I've got my inside fillets, and now I need to do the same thing to the outside fillets. And the inside fillet is 1 millimeter. The thickness is 1 millimeter. So to keep this thickness the same through that bend, the inside fillet 1 millimeter plus 1 millimeter thickness, that means my outside fillet needs to be 2 millimeters. So I'll go back to my fillet command, and I want to put this group together. I want to have 4 of these. There's 1, there's 2, there's 3, and there's 4. And this one is going to be 2 millimeters. When I do that, I get a nice shaped DIN rail, just like the data sheet tells me. Now I'm going to go add the slot. I'm going to go back to the back where that front plane is. Create that slot. And so again, looking at the data sheet, I'm going to make a circle. First thing I'm going to do is get on a sketch. I want to sketch on this face right here. So I can either pre-select the face and hit sketch, or I can hit the sketch button and then hit the face. Now I'm on this sketch plane. I'm sketching on this face. I'm going to go make a circle. I'm going to make another circle. Right click select to get out of the command. I want to make a line from here to here. I'm not being too careful. I'm just making sure I'm on the line. I want to right click instead of saying right click select. I want to right click and end chain. That'll keep me in the line command, and I can do it again over here. Right click select because I'm through drawing lines. Now I can look and see this has got a tangent. This has got a tangent. This side does not have tangents. They got coincidence but no tangents. So I need to make these lines tangent. That arc and that line need to be tangent. And again, I'm just selecting the circle, control clicking the line, and then making that tangent. Now I need some more geometric constraints. I need these two circles to be equal size. And I need these to line up vertically. The slot is at a weird angle, so I can select that, control click that, and then also I can control click the origin, line all three of those up vertically. Now I've got my nice slot. The only thing is I don't have a nice closed loop. I'm going to go into my trim command, trim entities, and I like to use this power trim that comes with the default. You click and hold and drag across entities, and it trims them back to the first entity it hits. So I'm going to click and hold and drag, click and hold and drag, and now I've got my slot. And now I can put my dimensions on there. That was a lot of work. There's got to be a better way, and there is. So I want to grab this geometry I just built and make this slot a different way by using this button here called straight slot. I've got different types of slots I can make. If I go to straight slot, I click once here, I click once here, and I click once here. That looks like a lot easier, and it gives me what I want. Now I'm ready to add dimensions. This dimension here, again from the data sheet. Oops, that's not what I wanted. I want to go from here to here. That needs to be 6.2, I believe. And I want to dimension the width of the slot. So I'm going to go from that arc to that arc, place that, and that's going to be 15 millimeters. But I look closely at the data sheet and see that it's 15 millimeters, but it's to this outer edge and outer edge of the slot. And so I want to make sure these dimensions match up exactly with the data sheet. So instead of trying to dimension to the center line, I want to select the dimension, get the properties over here on the side. I'm going to go to leaders, and there's options down at the bottom to change the arc condition from center to max, and watch what happens. Top one goes max, bottom one goes max. It's fantastic. I'm going to double click this and change this to 15. Now the slot is almost totally constrained. The only thing left is I need to know how far it is from the edge. And I know based on my slot cut rule that the dimension from the center of the slot to the edge of the part, which I can just grab this edge here. It's not on my sketch yet, but if I grab that edge, it'll put that edge in my sketch. And I can place that dimension and make that 25 divided by 2. I can type that in and it'll calculate it for me. And now I'm totally constrained, and now I can get out of my sketch, go do an ISO view, zoom into that back edge, and now I can pre-select the sketch. You'll notice it doesn't have a minus sign, which means it's fully constrained, which is what I'm looking for. And now I'm going to go back to features with the sketch pre-selected. Instead of extruded boss base, I'm going to do an extruded cut. It looks like it shows the right direction, and I want it not to be blind, but I want it to go through all. because the design intent is such that that slot always goes all the way through the DIN rail. Now I could do that a bunch more times, but what I want to do instead is, instead of making 80 separate cut extrudes, I want to do a linear pattern of the one I made, because those things just replicate down. So I'm going to pre-select the feature in the tree. I'm going to go find my linear pattern command, click it. Since I pre-selected the feature, it put it in the features and faces to do the pattern on. The blue box is highlighted. It's looking for direction 1. I can define direction 1 by clicking this edge. Once I do that, I can type in here the distance between each one is 25, and for a 2,000 millimeter DIN rail, we need 80 slots. So I type in 25 millimeter spacing, 80 total slots. Okay, now I've got all my slots in there. So the last thing to do is to define a material. You'll go to your data sheet and find the material. You right click on material and say edit material, and you can go find, Solidworks has a bunch of materials built in, and you can go find the material you want based on the data sheet information, and then define your material accordingly. Apply, close, and now the material is defined. And I've got my features all here. None of these sketches are underdefined, so this looks like a good model. So we will stop here for now, and we will go to the next step, which we'll be doing, changing the model from a good model to a great model by adding global variables and applying those global variables to the sketches and features.